The opinions expressed in the following program are strictly those of the speakers. They do not necessarily reflect the views of the National Science Foundation.
From the National Science Foundation, where discoveries begin. This is Frontier. Discussions of today's most exciting research subjects by distinguished scientists and engineers working at the frontiers of knowledge.
Hi, I'm Lisa Joy-Sikorsky with the National Science Foundation. Each year, the NSF recognizes an outstanding young researcher, someone under the age of 35 who is engaged in research in any field of science or engineering supported by NSF and enjoys noteworthy individual achievements. It is only fitting that in this, the International Year of Astronomy, we present the Alan T. Waterman Award to a truly stellar young scientist, David Charbonneau. An associate professor of astronomy at Harvard University, David is in town to accept this award. I'm thrilled that he could be with us here today. Also joining us are two of David's colleagues. Deborah Fisher comes to us from San Francisco State University, where she too is a professor of astronomy. She is also an accomplished exoplanet hunter, I am told. Jonathan Lunine is a professor of planetary science and physics at the University of Arizona. He joins us from the Gemini Remote Operations Center at the National Optical Astronomy Observatory. He's an interdisciplinary scientist on the James Webb Space Telescope. Thank you for being here, everyone. David, it may be said that your pursuits are out of this world, quite literally. Your research focuses on the development of novel techniques for the detection and characterization of planets orbiting nearby sun-like stars, exosolar planets, or exoplanets. Tell us more about your work.
Well, the main way that we've been looking for planets around other stars is to do a very straightforward thing, which is to watch them make little eclipses. And so the basic idea is that if this is the star, then we might actually be fortunate enough to see the planet pass in front of the star. And when it does so, it'll block some of the light. And so if we watch a very large number of stars and take pictures of them time and time again and very carefully measure their brightness, most of them will be dead boring, but every once in a while we'll find one that makes these little eclipses and gives us a first hint that there might be a planet orbiting that star.
Jonathan, Deborah, you too are engaged in the search for exoplanets. How does your work compare to David's? Is it different? Let's start with Deborah.
Okay, thank you, Lisa. The technique that I use is sometimes called the wobble technique or the Doppler technique. And what we do is go to the observatory, measure the speed of the star, night after night, month after month, year after year, however long it takes the star to complete one orbit. And then we mathematically model our data to identify the inferred planet that's orbiting the star. And this is a technique that it actually came first. We found the first planets this way. And I think people were very skeptical about the planets that were found with this technique. And it wasn't until really the transiting planets were found that people were completely convinced.
Jonathan, is your work similar?
Well, my work's very different, Lisa. I'm mostly a modeler, and I look at how planets form and what their properties might be like as they evolve over time. These numerous planets now, well over 340 planets that have been discovered, are quite a variety, very different from that of our solar system, and in terms of their individual properties different from the planets of our solar system, at least the ones that we can study, the exoplanets we can study. But I'm also involved in the James Webb Space Telescope, and we hope with that spaceborne infrared telescope to be able to study directly planets that are perhaps only a couple of times the size of the Earth, orbiting around the smallest stars, the M dwarfs. And if some of those planets indeed pass right in front of their stars we may be able to get the composition of their atmospheres, tell whether there's water, carbon dioxide in the atmospheres. That's a very exciting prospect for the next decade.
So it seems the loaded question is there life on other planets? What are the indications? David?
Well, I think that's one of the most exciting questions that as scientists we could pursue, and I think my colleagues feel the same way. What's remarkable is that, if you look back through history, you'll find that humans have been thinking about this question for millennia. But up until now, we've had to just use our imaginations. Whereas we happen to be alive at this very special moment in human history, where for the first time we'll have the technological ability to actually detect that life if it's out there. And so we really will be able to go out and do a survey and see if there are inhabited worlds out there in the galaxy, or we may find out that in fact the Earth is a cosmic rarity. What's exciting is that really in the next 5 to 10 years, I think we'll be able to actually undertake that work.
Deborah, do you think the world is, as we know it, our planet, our planetary system, our Earth is rare, or do you think there are others like it?
I guess if I had to bet, I would bet that there are a lot of worlds like ours orbiting other suns like our sun. They probably, many of them probably orbit at the right distance from the sun so that it's not too hot and it's not too cold, but it's just right so that liquid water can pool on the surfaces of these planets. But if we've learned any lessons at all, it's been, as Jonathan said, that the diversity of planets is stunning. I think that's the thing that's amazed us all the most. And so whether these other worlds, even if they're just the right mass at just the right distance, host life or not is yet to be determined. They could be water worlds, for example, where there's plenty of life, but it's, aquatic life. And so not the kind of life that's going to be sending radio signals and using cell phones and things like that.
And Jonathan, do you agree, or do you have a different perspective?
Well, I agree with the possibility that planets are all very, very different from each other. In fact, the exploration of our own solar system has the results of that have pointed out very strikingly the contingency associated with planetary evolution. If you look at the Earth and you look at Venus, which are essentially identical in size, Venus is just a little bit smaller, they've had completely different evolutionary trajectories. Venus is closer to the Sun than the Earth is, but not by very much, and yet it has an extremely different environment that is completely inhospitable to life. So we have to be prepared for contingency and prepared for planets that, as Deborah said, are very, very different from that of the Earth. The big challenge, once we get to the point where it's possible to study the atmospheres of other planets, will be to decide what are the signatures of life that are detectable in these planetary atmospheres. We think of oxygen as a signature of life, but that's a signature of advanced life. Primordial life would not produce a large oxygen signature in the Earth's atmosphere or the atmosphere of an exoplanet where there is primitive life. So it's going to be a challenge to determine just what signatures of life are reliable and can be used to identify planets around other stars that have life.
And how are we observing these exoplanets? I understand there's space-based observation methods and there is also land-based. Perhaps you could compare and contrast the two and then describe your own work. Maybe David, we'll start with you.
Sure. Well, I think there's this wonderful interplay between ground-based observations and things we do from space. I think it's fair to say that most of the planets have been discovered by ground-based telescopes, both with the eclipsing method we talked about and with wobble method that Deborah talked about. That's work done with ground-based telescopes, and yet when we find those systems, then we hand them off to some of the big space-based telescopes like the Hubble Space Telescope to pursue follow-up studies, and that's really how we characterize their atmospheres and figure out the chemical content of those atmospheres. Is there water? Is there methane? Is there carbon monoxide? You really need to get clear of the Earth's atmosphere which of course contains some of those things, to be able to know for sure that you've detected that on the atmosphere enshrouding another world. And so I anticipate that that relationship between ground-based astronomy and space-based astronomy will continue in the future as we move from studying these sort of big gassy worlds like Jupiter and Saturn that we've been doing for the last 10 years into the characterization of the smaller rocky worlds that of course might be habitable and even that much more exciting.
Deborah, do you have a preference in your research? The work that I've been doing is all with ground-based telescopes. And I think it's important to think about the price tag of all of this work, and to approach this in the thriftiest manner possible, the most sensible manner, where we, for our investment, get the most science. And so, as David said, the ground-based work that's been done has really laid the foundation and educated us about the types of space missions that we want to fly and the types of instruments that are needed on those space missions to make big inroads. So they're definitely, they go hand in hand, and perhaps the best example is the Kepler mission, which was just launched on March 6th, and will, like David's work, will stare at a deep field and will look for transiting planets, and will very much need the help of ground-based telescopes to follow up those detections.
The price tags are certainly a strong consideration. There's no secret that we face severe economic challenges in our world today. Gentlemen, lady, what do you say to the skeptics who argue that we should be focusing our research and our resources here on the Earth instead of looking for life on other planets? Who wants to take that one first?
Well, I'll start. First of all, I want to say that it tickles me that every night, only about 10 miles from my house, one of David's installations, which is a set of small telescopes that would be familiar to an amateur astronomer, are searching automatically for planets around the smallest stars, the M dwarfs. And this is a relatively inexpensive setup when you look at the size of big missions and the cost of big missions. So I can go to bed every night knowing that David's equipment is out there a short distance from me doing all this work. Nonetheless, even the most expensive of the space missions, for example JWST, is a very, very small fraction of the cost of, for example, the bailout of banks in the United States that we've seen over the last few years. These bailouts could literally fund dozens and dozens of telescopes like JWST. Now, I'm not suggesting that we redirect our money that way, but the point is that while we should and are taking care of our economic health and our social needs in this country today, we can and should reserve a small fraction of that money to answer fundamental questions that have perplexed humanity throughout its history. And the fact that we are a nation with such wealth means that it's possible to do this search with these marvelous machines in space for a very, very small fraction of these other economic needs and priorities.
David, can you speak a little bit more to the investment? What will determining whether there is life on other planets, what implications will that have for our life here on Earth?
Well, I think the question of funding for science is a very important one, and we all need to think about, what do we really want from that? I think, I teach, and when I talk to my students, and I ask them, are you interested in whether there's life elsewhere in the galaxy? Then they all seem to be absolutely riveted by that question. And then I point out to them that we don't know the answer, that it could be that there really is life orbiting planets, life on planets orbiting other stars, or it really could be that we're alone, really alone. And I think that, beyond just the scientific implications, which would be very deep, it wouldn't just be astronomy, it would affect our understanding of how life got started here on Earth, and what are the necessary ingredients for life, and is it just a matter of assembling all the right stuff on a planet and making sure it's at the right temperature for liquid water, or not? Is there much more to it? I think that all of us would be deeply affected in terms of a sense of ourselves in the universe. And I think that's really what astronomy can provide to our society, is a much deeper understanding of our scale. How big are we compared to the universe? How long do our lives last compared to the age of the universe? It really, I think, is very humbling, and I think it is the mark of a great society to pursue these very deep questions. And I think that, frankly, the question of life and the preponderance of life in the galaxy is the deepest of those. And so the question is that worth a few dollars per person to pursue? But that's something that each of us have to really decide.
Well, in one way, I'm entirely encouraged, because in one way we are not alone. There is now a commitment at the highest level. President Barack Obama has stated his commitment to support research, funding for science and engineering, and I'm incredibly encouraged. Tell me about all of you. You're on the front lines of research. How does it feel, and what are your prospects for the future? Deborah, why don't we start with you?
Well, this is absolutely validating, and it's a struggle. We see a lot of our students come through. They're working to get postdoctoral fellowships and then to go on in the field. And there's so much potential in the resources that we have. I wanted to add that, the discoveries that we're making are inspiring students who are in grade school, who are in high school, and even in college to take up science as a career. And so the commitment for funding for science at the highest level now, I think, encourages students even more. It highlights the importance of science. And the fallout from that is much greater than just our little field of astronomy. Of course, the discovery of life would impact religions and philosophy and everything. But we really intersect with so many other disciplines like computer science and the CCD technology. And so the interaction, the interplay between astronomy and other fields is profound, and it changes people's lives in ways that they don't even realize with cell phones and other devices.
Jonathan, do things look brighter on your front?
Things certainly are much more positive today, and President Obama's speech to the National Academy last week was very exciting for the commitments that he made. At the same time that we can move forward with all of these exciting prospects, it's important that we complement that with new educational programs that bring the results of these exciting endeavors to the general public, to kids in elementary school, in middle school, high school, and on to college. One of the things that has been of concern to all of us is the lack of deep science knowledge among people in the United States and also elsewhere to some extent. And that's something of great concern, because it will be impossible to continue these endeavors if the public who pays for them is not with us and not understanding these things at a fairly significant level. So education is crucial as we move forward with these very exciting programs. I'll add, by the way, that while these questions are exciting to people, it's interesting to me that many people have made up their minds already. When you ask somebody what they think about the discoveries of planets around other stars, many people will say, oh, I knew there were lots of planets around other stars. People have been influenced by the popular media, Star Trek, Star Wars, and so on. And so convincing people that this search has been a heroic accomplishment is in some ways difficult, because the Copernican assumption that we have in our society is that planets should be common and life should be common throughout the universe. But we, as David said, we do not know that, and it is this search that ultimately will tell us that.
Okay, you mentioned it, Star Trek. Has anyone seen the movie? And if so, what do you think?
Oh, me? Of course I saw the movie.
Absolutely.
I will be seeing the movie. I was camping in the mountains this weekend, and then I had to go to the decadal survey meeting on Monday. So instead of spending my Monday with Captain Kirk and Mr. Spock, I spent it with a bunch of scientists. But I will see the movie.
There is a connection, which is that many of us refer to one possibility, namely if there really is, if all stars host planets with life. We actually call that the Star Trek universe in astronomy. And so, if you're talking, for example, about the Kepler mission, which really is doing this first survey to find analogs of our own solar system. Are there really Earth-like planets at the right distance from sun-like stars for water to be liquid? In Star Trek, there'd be 2 of them for every star. But we really could find that, unfortunately, we don't live in the Star Trek universe, that the prospects for travel or communication are very dim. And that is, to our best of our searches, there are no such worlds. But Hollywood has really, kept up kind of our inspiration, I think. They've done a great job of that. I think, science fiction has been very important to me in terms of big blue sky thinking for the future. But now the time has come to actually go and find out which of these 2 possibilities, which of these 2 universes we actually inhabit.
Deborah, Jonathan?
I was a Trekkie as well. I am a Trekkie, and I used to go to Star Trek conventions as a teenager. It's interesting that the origin of the Star Trek universe is not really with Gene Roddenberry. It's really with Giordano Bruno back in 1600, who wrote his own brand of science fiction inspired by Copernicus's model of the Earth not being at the center of the universe. And he didn't call it science fiction, it was a philosophy. But he said that there are essentially innumerable worlds around suns like our own, and he identified the sun essentially as being just one star. And this was an assumption, really. He said that on each of these planets they were no better or no worse than our own, which implied that there was life there. And this was really, from 400 years ago, the original Star Trek vision. And so it's been with us for a very, very long time. And for that reason, it's deeply ingrained in Western philosophy and Western consciousness. And so we live in an incredibly peculiar time when we will actually be able to test this 400-year-old assumption that in many ways underpins Western philosophy.
Deborah, has Star Trek and popular culture fueled your interest in science as well?
Absolutely. I mean, I was reading Isaac Asimov and Robert Heinlein when I was a teenager and fell in love with science and science fiction because of them. And so it's inspiring, and it's still, a lot of fun to think about. The science fiction writers certainly pushed us to think that planets were common around other stars. As David said, many stars would harbor 2 planets. And as Jonathan said, Venus is very much like the Earth. And if only Venus had formed out where Mars is, they maybe had switched places, we would have had 2 habitable planets in our own solar system. And I often think how that might have changed our perspective of what exists around other stars and what kind of life there might be. So it's played a huge role and still does.
A few minutes ago, Jonathan mentioned the decadal survey. I understand that all 3 of you are working on this project. Tell me about it, and how are you involved?
Well, Jonathan, would you like to start?
Sure, I'll start. The National Academy of Sciences does what's called a decadal survey for astronomy and astrophysics every 10 years. I believe this is the 5th of this series, and they're very influential in establishing priorities, particularly for large projects in astronomy, for the following 10-year period. And so here we are with the present decadal survey that is coming on the cusp of all of these remarkable discoveries of planets around other stars. And so we're poised to take big steps to get to where it'll be possible to see and study an Earth-sized object around a star like the Sun. To do that will require, as David and Deborah said, both small projects and large ones. The large ones will have to be reasonably high priority within that decadal survey for them to be implemented in the next 10 years. And so from the point of view of exoplanet hunting, there are very high stakes in this particular decadal survey, more so than in the past one. I would point out as well that one predecessor report to this decadal survey, which Deborah and I were involved in, was the Exoplanet Task Force of the Astronomy and Astrophysics Advisory Committee. And there we laid out a strategy for going from present-day capabilities to the point at which it will be possible to study the atmospheres of Earth-sized planets around stars like the Sun. That may not be the route that the decadal survey takes. It's one possible flavor of how we could get from here to there.
So that seems like the macro level of feeling inspired and interested in how to shape the field. What about the individual level? Has each of you experienced what we call an aha moment? You had mentioned the eclipsing, identifying an exoplanet. Was that yours, or tell me?
Sure. Yeah, I've been very fortunate to have that aha moment. I think that it's a great joy. It's what every scientist hopes for in their career, and that's right. I was working with one of my graduate advisors, a guy named Tim Brown, and we had deployed a very humble telescope. It was a 4-inch telescope, so about that big, and we'd set it up in a parking lot next to the building where we worked in Boulder, Colorado, and we were studying a planetary system where we knew there was a planet because there was a Doppler wobble, but no one had ever seen one of these eclipses, and the eclipses would be very important because all of a sudden, if you knew the planet passed in front of the star, you could measure the size of the planet, and by measuring the size of the planet, that would allow you to, combine with the wobble, actually figure out the density, and then by inference the composition. So we'd be able to learn whether the planet really was a ball of gas like Jupiter, or whether it was a ball of rock like a super Earth. And indeed, I went out there. I remember there was clouds, and I had to go back night after night, and we were, waiting for people to turn off their lights and leave for the day so we could start up the telescope because it was sitting out in this parking lot. And lo and behold, we managed to measure the first transits for the system. And those were the first time anyone had seen these eclipses, and that was an absolutely just glorious moment. And I was very fortunate to have that as a graduate student. And so, as you can imagine, that just really inspired me to continue working in the field, and I've enjoyed it very much. I want to just say that, of course, since you can do this, since they're discovered with these small telescopes, then we can give that moment to students as we teach them in high school and in colleges, right? Because any high school or college, university can think about building a telescope. It's a sort of an amateur-sized telescope, and so you could imagine using a telescope like that with students and actually have them prove for themselves that there's a planet orbiting another star. They can actually do it with a telescope about that big, and so those are pretty modest in cost, and so it's not unreasonable to do that at the high school level in many of our schools.
Jonathan, have you experienced such?
Well, actually, I'll let Deborah talk first because she's experienced a lot of aha moments.
Well, I would say David's aha moment was an aha moment for the entire astronomical community, and also a moment of relief for us who had been sort of finding these planets by the wobble technique. But I think for me, there have been a couple of moments. The first one was when we found a planetary system, in fact, a system of 3 planets, not just one planet orbiting the star. And looking at the architecture of that system, we could tell that this system was pretty full with planets. It would be hard to drop another planet in and have it survive in this system. And that meant that this was a system that shared something with our solar system. It was gravitationally full of planets. There weren't other places you could just drop things in. And we'd been finding so many examples of how other solar systems were different from our solar system that this was reassuring and exciting, and it fed into the idea of how planets form. And so that was an incredible moment, and it was fun to be able to sit there and model it and see that in fact, just modeling with 2 planets wouldn't work, and it was only putting in the more complicated mathematical model for 3 planets that finally everything just fit like a glove. and then rush up to the observatory, observe the star the next night, and have that next data point fall right on the predicted curve made me feel powerful. You know, I predicted the motion of the star. And then also just, you know, I think there are other examples too, just better understanding the correlation between the chemical compositions of stars. I remember I'd worked hard for about 4 years before I finally laid down the plot that showed this correlation between heavy elements and the presence and formation of gas giant planets. So those are the things that really, I think, drive us and that we live for, make it all worthwhile.
And that's
so I have not had aha moments. I've had, my goodness, they actually did it moments throughout this 20-year period, this 12-year period, 13-year period. You know, first when the first detections of planets were announced by the wobble technique, the one that Deborah and her colleagues used, they were all big planets and they were close to their parent star, and so the natural tendency was to say, well, that's great, but they'll never be able to see things that are closer in size or orbital distance to planets in our own solar system. But then they did it, and they kept bringing the wobble technique to a higher and higher level of accuracy, and the rest of us were all amazed. And then when there were enough of these discovered that, in fact, some of them turn out to pass in front of their parent star by the transit technique, several of us began to model what you could do by looking at different colors of light as these planets passed in front of their stars and pulling out the composition of the atmospheres of the largest of these. But there was some disbelief, certainly by me, that anything but the most evident molecules or atoms could be plucked out. And so along came David Charbonneau and his colleagues, and they've been finding all sorts of different things in these atmospheres. So it was once again a, my goodness, they did it kind of feeling. So I feel like I'm on an astronomical thrill ride that's being controlled by David and Deborah and colleagues, and I'm just waiting to see what they come up with next. So imagine a time, David, when your daughters are grown up and they have children. They take their children camping, and instead of having their kids look at the sky and wonder whether there are habitable planets around some of those stars, that your daughters can actually point to some of the stars in the sky and say, there's a planet like the Earth orbiting around that star. That's completely different from any other kind of camping trip in human history, isn't it?
Yeah, I actually have to say that camping was a very big part of growing up for me. I was in the Scouts and used to go camping and bring my star map and look up. But that was at a time when we didn't know of a single star with a planet orbiting it. And indeed, I look forward to the near future where, that's right, I think my daughters will grow up in a world in which there are always planets orbiting other stars, right? In high school, they will have been taught that we know that. And they themselves, may pursue careers not as astronomers, but as maybe astrobiologists, who actually get to do more than just be involved in the detection, the kind of grunt work that we all have to do now, but actually get to think about detecting life on those worlds and what that means for the basic processes and the robustness of life and the basic conditions under which life forms, and really flesh out this very exciting possibility of astrobiology, which I think is at hand. So it's amazing how quickly our scientific knowledge of the universe can change right now with the research that is, of course, right now in astronomy.
This has been a fascinating interview. Do any of you have final parting words for the next generation of scientists?
I guess my parting words are somewhat cautionary that this remarkable pace of discovery that we've experienced in the last decade is unusual, not only in human history, but even in the history of astronomy. And I certainly hope it will continue, but we have to recognize what a remarkable time it is. I would also say that in the search for life, we have to recognize that the hunt for life elsewhere is predicated on the life that we know, which is life on Earth. And all life on Earth is based on the very same fundamental molecules, DNA, RNA, proteins, life could be very different on other planets, and whether we'll be able to expand our minds enough to encompass those possibilities and establish whether life exists on other worlds, if that life is really exotic, is a very, very pressing question. It will take a range of fields in science, biology, chemistry, astronomy, planetary science, to make that happen. So the search is exciting, it has momentum, but ultimately it's going to be difficult and challenging. But I think we'll get there.
Deborah?
So I would encourage all students to study every single subject, because you need to be flexible. The sorts of things that I'm doing now, I wasn't trained to do even in graduate school. And we have to think out of the box. And especially I want to encourage the young women, the girls, to be bold and to embrace mathematics. And when you get in middle school and high school, don't back down. Sit up in the front and you can do it. You just have to try.
Deborah, Jonathan, thank you so much for joining us remotely. And David, congratulations on your award, and it has been my pleasure. Again,
Thank you.
I'm Lisa Joy Zagorski with the National Science Foundation. Thank you for joining us.